Brad Williams, Frugal Finance, structured notes, the inverse floater, an inverse floater rate note, or inverse floater as a payoff pattern that is inversely related to a floating reference rate. An inverse floater is also known as a reverse floater or a bull FRN. It is called a bull FRN because it is attractive to those who are bullish on bond prices, expecting lower interest rates. For example, assume that 6-month SOFR now stands at 7%. An inverse floater might promise to pay a floating rate of interest equal to 14% minus 6-month SOFR. The initial yield on the inverse floater would be 7%. As SOFR rises, however, the interest paid on the inverse floater would fall. If 6-month SOFR rose to 9%, for example, the note would only pay 5%, the 14% minus the 6-month SOFR of 9%. If SOFR fell from its initial level of 7%, the rate paid on the inverse floater would rise. The inverse floater. For example, a 6-month SOFR of 5% would require a payment on the inverse floater. For example, a 6-month SOFR of 5% would require a payment on the inverse floater of 9%, which equals 14% minus the 6-month SOFR of 5%. Consider this same floater if SOFR rises to a level above 14%, say 17%. The terms specified so far would require the purchase of the bond to pay the issuer because the payment on the bond is supposed to be 14% minus SOFR. Almost all inverse floaters include the stipulation that there will be no interest payment if SOFR exceeds the stipulated fixed rate, which is 14% in our example. This amounts to the inclusion of an option with the inverse floater. It also explains why the fixed rate should be set quite high relative to SOFR floaters, so that SOFR will be unlikely to exceed the fixed rate during the life of the bond. An example of an inverse floater, consider a firm that issues a $100 million inverse floater that has a maturity of 5 years and pays annual interest equal to 14% minus 1 year SOFR. The issuer can create this instrument without using the derivatives market, but in the creation of structured notes, it is common for the issuer to use derivatives to maintain a traditional interest rate exposure for itself, while offering a non-traditional payoff pattern to investors. Thus, we begin the analysis of this inverse floater by assuming that the firm issues the inverse floater and uses the swap market to avoid the inverse pattern of interest expenses. Later, we show how to create the issuance and purchase of synthetic inverse floaters from the same elements. Think about this, and how are you going to sell this particular product to somebody that is naive? Well, if they're naive, they're going to look at this 14%, and you as a salesperson are going to push this 14%, and then you will just casually discuss all of the variables. And the person on the other end is going to look at this going, wow, 14% in a 4% market. That seems too good to be true. And you as a salesperson are going to do what you have to do to get that sucker to buy it. But a smart CFO is going to go, I'm not buying your bullshit. Here you are, you're covering your rear end by using swaps to hedge yourself, but you're trying to get me to buy this thing. Show me the numbers. Show me the numbers, then we can talk. Assume that the issuer of the inverse floater also initiates a received fixed swap with terms that match the inverse floater. Specifically, the received fixed swap has a 10-year, 5 years, and a floating rate payment equal to 1 year SOFR. The notional principal for the swap is $200 million, which is twice as large as the principal on the inverse floater. We refer to this kind of swap as being double-sided because the notional principal on the swap is twice as large as the large principal. Assuming that the yield curve is flat at 7%, the swap fixed rate will also be 7%. Figure 22.7 presents 3 cash flow timelines pertaining to various features of this inverse floater. The first timeline of figure 22.7 shows the cash flow obligations associated with the inverse floater. Each period, the issuer pays $14 million less SOFR times 100 million. It is useful to think of the issuer as paying 14 million and receiving SOFR times 100 million under the terms of the inverse floater. The second timeline shows the cash flows for the double-sized received fixed swap. The inflow is the SOFR of 7% of 200 million. The third timeline shows the combined cash flows from the issuance of the inverse floater and the received fixed swap. Except for the cash flow involving the principal on the loan, the annual cash flows are all the same. Therefore, we consider the cash flows at year 3 in detail as representative of the cash flows on the entire financing agreement. Here we have example 1, example 2, example 3. Here's just the layout of what I just mentioned. As the preceding analysis shows, for each year, the fixed cash flows net to zero. This leaves only floating cash flows. The inverse floater gives the issuer a cash inflow tied to SOFR that offsets the 14% fixed rate. The received fixed swap requires a floating cash flow tied to SOFR on 200 million. The net result is an annual interest payment equal to SOFR on 100 million. In sum, the issuer has issued an inverse floater but combined with a received fixed interest rate swap with a notional principal twice as large as the debt issuance principal. The net result is the same as the issuer having issued an FRN with the original desired principal. The final timeline of figure 22.7 reflects the result. It is exactly the same cash flow pattern for issuing a straight FRN with a principal of 100 million. Still viewing matters from the point of view of the issuer, we may view this transaction in 2 ways. We have just seen issuing an inverse floater plus initiating a double-sized received fixed swap is equivalent to issuing an FRN with a principal that is the same as the principal of the inverse floater. For a common notional or principal amount, figure 22.7 effectively says the following: decomposition of an inverse floater. Issuing inverse floater plus double-sized received fixed swap equals issuing an FRN, or issuing an FRN plus a double-sized received fixed swap equals an inverse floater, or because being short a received fixed swap is the same as being long a pay fixed swap, the equivalent position is as follows: synthesizing issuance of an inverse floater, issuing an FRN plus double-sized received fixed swap equals inverse floater. This gives a formula for synthesizing the issuance of an inverse floater. We consider the year 3 cash flow for the issuance of the inverse floater synthesized by using an FRN and initiating a pay fixed swap with a notional principal of this right here. We now consider the inverse floater from the point of view of the investor. If firms or agencies issue inverse floaters, the investor can simply purchase one. Alternatively, the investor can also create an inverse floater for herself. As we have seen, the issuer can synthesize the issuance, so the investor must be able to synthesize the purchase. A synthetic purchase will be just the opposite of a synthetic issuance. If we reverse all the positions for the synthetic issuance in equation 22.7, we'll have the formula for the synthetic purchases on the inverse floater. Synthetic purchase of an inverse floater, issuing an FRN, double-sized received inverse floater. Equation 22.8, purchasing an FRN, double-sized received fixed swap equals purchase inverse floater. Equation 22.8 gives the formula for the purchase of synthetic. Year 3 cash flows on the synthetic inverse, SOFR times 100 equals purchase an FRN, plus 14 million minus SOFR times 200 million, double-sized received fixed swap. Results, negative 14 million minus SOFR times 100 million, synthetic inverse floater purchase. As we have seen, any investor with access to the swap market can make her own inverse floater investment by buying an FRN and entering a double-sized received fixed plain vanilla interest rate swap. Nonetheless, the market for issuing inverse floaters is fairly large, with billions of dollars of principal being issued each year. This continuing issuance apparently reflects the greater operational efficiency of larger firms and agencies in creating this kind of instrument. Brad Williams, Frugal Finance. Thanks for watching.